True. Right now, everything you can see, everything you touch, every single thing that makes you you is running on electrons. Billions of trillions of them. And what I'm about to tell you is that maybe, just maybe, there's only one. Not one type. One. A single electron doing every job in the entire universe at the exact same time. True. Sounds completely insane, right? Here's the part that'll mess with you though. This wasn't some random guy on the internet at 3 a.m. This came from one of the smartest physicists who ever lived. And instead of hanging up the phone, he turned it into a Nobel Prize. So before you scroll away, ask yourself one question. True. What if you aren't made of a giant crowd of particles at all? What if you're made of the same one over and over and over again? Stick with me, because this gets a lot weirder than it sounds. Picture this. It's a cold night in 1940, Princeton. A young grad student named Richard Feynman is sitting in his room when the phone rings. True. On the other end is John Wheeler, his professor, an absolute legend, the guy who would later coin the term black hole. And Wheeler doesn't even say hello. He just goes, "Feynman, I know why all electrons have the same charge and the same mass." And Feynman, half asleep, goes, "Why?" And Wheeler drops the bomb. True. Because they are all the same electron. Now hold up. Let's rewind for a second, because to feel why that sentence is so nuts, you first need to understand the mystery Wheeler was actually losing his mind over. Here's something nobody really tells you in school. Every electron ever measured, anywhere, in any lab on Earth, inside any star, in your phone, in your brain, is exactly the same. Same mass, same charge, same spin. Not basically the same, not close enough. Identical to a level of precision that should honestly freak you out. Think about it like this. Go grab two apples. Even from the same tree, they're different. Different weight, different shape, tiny little scratches. True. Snowflakes, all different. Fingerprints, all different. In the real world, copies are never perfect. Nature is messy. That's kind of nature's whole thing. But electrons, flawless. Trillions upon perfect clones. And not a single one is even slightly off. There's no factory, no quality control department. So how? True. How does the universe keep pumping out perfect copies with literally zero variation? And it gets weirder. In quantum mechanics, electrons aren't just identical, they're indistinguishable. Meaning if I secretly swap two of them while you blinked, there is no experiment, none, anywhere, that could ever tell. True. The universe doesn't just treat them as equal. It acts like there's no difference to even talk about. It's almost like the universe itself can't tell them apart. And that little detail, that's the thread Wheeler pulled on. Because his answer was basically, what if the universe can't tell them apart? Because there's nothing to tell apart. True. What if there's just one? So picture a single electron. But instead of just sitting still in time, it's zigzagging, shooting forward through time, then backward, then forward again, weaving through the entire history of the universe like a needle through fabric. And here's the trick that makes your brain itch. If you freeze one single moment, one now, and take a snapshot, that one thread passing back and forth would show up as millions of separate dots. You would swear you were looking at a massive crowd of electrons. But it's one, just woven through time so many times that a single slice of now looks absolutely packed with it. Let me make that real for you. Imagine sewing. You take one thread, one needle, and you stitch up and down through a piece of cloth. Up, down, 100 times. Now flip the cloth over and look at only the surface. You see 100 little points where the thread pokes through, 100 separate dots. But there was only ever one thread. That surface, that's our present moment. Those 100 points, those are all the electrons. Same needle, same thread. One particle stitched through time. Okay, but I already know what you're thinking. You're thinking, that's cute, but an electron can't just go backwards in time. And this is where it goes from weird internet theory to actual, real physics textbook stuff. Because when an electron runs backward through time, it doesn't look like an electron anymore. It looks like its evil twin, a positron. Antimatter, same mass, opposite charge. And this is not hand-wavy psi nonsense. This exact idea that a positron is just an electron moving backward in time is baked directly into the equations. Physicists use every single date to describe reality. Feynman literally built his famous diagrams around it. So the picture becomes beautiful. One electron, surfing forward as matter, then flipping around and running backward as antimatter. Back and forth through, threading the whole universe together into one single continuous line. Honestly, at this point, it almost feels too good to be true. And here's the thing, it kind of is. Because if you're really paying attention, there is a massive glaring problem with this whole gorgeous idea. And Feynman spotted it instantly. If a single electron is going forward and backward in equal amounts, then there should be exactly as much antimatter as matter in the universe. The same number of positrons as electrons. A perfect 50-50 split. So Feynman asks Wheeler the obvious question. Okay, Professor, then where is all the antimatter? Why is the universe made almost entirely of matter? Where are all the positrons hiding? And this is the twist that flips the entire video. Wheeler didn't have a good answer. He mumbled something about the missing positrons, maybe hiding inside protons, and Feynman knew immediately that was wrong. So technically, the one-electron universe, taken as a literal statement, doesn't hold up, it breaks. Feynman himself never actually fully believed it. So case closed, right? Fun little story, cute idea. Physics said nope, everybody go home. Except that's not where it ends, not even close. Because that wrong idea did something almost no wrong idea in history ever does. That midnight phone call, that crazy throwaway line, it planted a seed in Feynman's head. The part about electrons and positrons and time running in both directions, he took that one piece, ran with it, and it became a core part of quantum electrodynamics. And quantum electrodynamics is the most precisely tested theory in the entire history of science. We are talking about predictions that match reality to more than 10 decimal places. Let me put that in perspective. That's like measuring the distance from New York all the way to Los Angeles and being off by less than the width of a single human hair. That level of insane, ridiculous accuracy. And Feynman won the Nobel Prize for it in 1965. And in his Nobel speech in front of the whole world, he brought up that phone call, the wrong idea, the one electron. He never forgot it. So here's the real mind bender to leave you with. The literal story, one particle physically zigzagging through all of time, probably isn't true. But the deeper question Wheeler was chasing, why is every electron a perfect, flawless copy? That question is very real. Modern physics has an answer that is somehow even stranger than one electron. In quantum field theory, an electron isn't a tiny little ball at all. It's a ripple, a vibration in an invisible thing called the electron field. A field that fills all of space, everywhere, all at once, right through you as you watch this. And every electron in existence, the ones in your eyes reading these words, the ones in a galaxy a billion light years away, is just a little bump in that one single field. So they're identical for the simplest reason imaginable. They're all made of the exact same underlying stuff. Same field, same source. One thing showing up everywhere. Wheeler said one electron. He was off. But one field, one shared source that every single electron springs out of. That is basically the world we actually live in. So the crazy man on the phone wasn't right, but he wasn't exactly wrong either. He was staring straight at something true, just from a really weird angle. And that right there is the thing about physics. Sometimes the wildest, most obviously insane idea, the one everyone wants to laugh at, is the exact one that cracks the door open. So the next time you look in the mirror, remember this. Every particle in that reflection might trace back to one shared cosmic thread. You are not separate from the universe. Standing outside of it looking in, you are stitched into it. Literally. If this rewired your brain even a little bit, do me one quick favor. Smash that like button. It genuinely helps this channel way more than you'd think. Subscribe if you want more physics that actually feels like a story instead of a boring lecture. And drop a comment down below. I really want to know. Do you think there's truly only one electron out there? Or is that one step too far into crazy town? I read every single comment. I'll catch you in the next one.